Good morning all. Last day we have the concept of rings and examples of rings were introduced. A ring is an algebraic structure R plus dot with three axioms called known as ring axiom. R1 is R plus is an abelian group. R2 is with respect to multiplication it is associative. R3 is the left and right distributive laws hold. Today we have one more problem of rings and some elementary properties of rings were introduced. So elementary properties of ring were introduced. Before that we are doing a problem. Compute the product minus 3, 5, 2 minus 4 in Z4 cross Z11. So the first minus 3 is in Z4 and 2 is in Z4 and 5 and minus 4 in Z11. So first we have to find minus 3. Minus 3 in Z4 is equal to minus 3 in Z4 is equal to 1. Since 3 plus 1 is equal to 0. So minus negative of 3 is 1. And minus 4 in Z11 is equal to minus 4 plus 7. 4 plus 7 is equal to 0. 11. That is the remainder equal to 0 in Z11. The remainder obtained when 11 is divided by 11 is 0. So 4 plus 7 is equal to 0. Therefore minus 4 is equal to 7 in Z11. Therefore minus 3, 5 into 2 minus 4 is equal to, instead of minus 3 we could write 1, 5 and 2 minus 4 is 2, 7. Now we have to find the product. This is 1 multiplication modulo 4, 2. 5 multiplication modulo 11, 7. 1 multiplication modulo 4, 2 is equal to 2. 5 multiplication modulo 7, modulo 11, 7 is equal to 5 into 7, 35. 35 when we divided by 11, after 3 into 3, 33. 3 into 11, 33 plus 2. So the remainder is 2. Therefore the answer is 2, 2. Now we have the elementary properties of a ring. Let R plus dot be a ring with addition identity 0. Then for any ABC element of R, 0 into A is equal to A into 0 is equal to 0. A into minus B is equal to minus A into B is equal to minus of A into B. Third property is minus A into minus B is equal to AB. Fourth one, A into B minus C is equal to A into B minus A into C. And B minus C into A is equal to B into A minus C into A. Now first one, proof of 0 into A is equal to A into 0 is equal to 0. Now by ring axioms R1 and R3 we have A into 0 plus A into 0, which is we can use the distributive law. So which is equal to A into 0 plus 0. That we could write is 0 plus 0 is equal to 0. Therefore H is equal to A into 0. Now A into 0 can be written as 0 plus A into 0. So we can, if we, the first term of this equation is A into 0 plus A into 0, which is equal to 0 plus A into 0. Therefore we can use the cancellation law for the additive group R plus, then this becomes A into 0 is equal to 0. Similarly 0 into A plus 0 into A is equal to 0 plus 0 into A, which we could write 0 into A, which is 0 plus 0A, which implies using the cancellation law 0 into A is equal to 0. Now the second one is we have to prove that A into minus B is equal to minus A into B is equal to minus of A into B. To prove that A into minus B is equal to minus A into B is equal to minus of A into B, we have to prove that A into minus B is the additive inverse of A into B. A into minus B plus, that is we have to show that A into minus B plus A into B is equal to 0. So we are starting with A into B minus B plus A into B. Using the distributive law we could write A into, which is equal to A into minus B plus B. This is by left distributive law, which is equal to A into 0, since B minus B plus B is equal to 0, which is equal to 0 by property 1. Similarly A into B plus, now we have to show the ulta. A into B plus A into minus B is equal to 0. So take A into B plus A into minus B, which is equal to A into B plus minus B, which is equal to A into 0, which is equal to 0. Thus a into minus b is plus a into b is equal to 0. The first expression, which is equal to a into b plus a into minus b. That is the additive inverse of a into b is a into minus b. That is a into minus in b is equal to minus of a into b. Similarly, we can prove that minus a into b is the additive inverse of a into b. Therefore, minus a into b is equal to minus of a into b. Therefore, the old equation a into minus b is equal to minus a into b is equal to minus of a into b. Now, next property is proof of minus a into minus b is equal to ab. We are taking the LHS, minus a into minus b is equal to, we are using the first property. We could take the minus of that equal to a into minus of minus a into b. Since a into minus b is equal to minus of a into b, which is equal to, we could again take from minus a the negative, minus of minus a into b, since minus a into b is equal to minus of a into b, which is equal to a into b. Now, last proof a into b minus c is equal to a into b minus a into c, and b minus a into a is equal to b into a minus c into a. A into b minus c is equal to a into b plus minus c, which is equal to a into b plus a into minus c by left distributive law, which is equal to a into b plus minus a into c. This is by using property 1, which is equal to a into b minus a into c. Also, b minus c into a is equal to b plus minus c into a, which is equal to b into a plus minus c into a. This is using right distributive law. That we could write b into a plus, we could take the minus outside, minus of c into a by property 1, which is equal to b into a minus c into a.